Hello everyone, my name is Swastik Nepal and I am from the British College. So here we have an assignment of the ASE, Advanced Software Engineering, in which we have been asked to use the BOOSE library, which gives us the command to draw in our canvas. Using .NET, I have made a drawing, I have made a draw through command interface, which we can see here, and I'll explain you later while we move in the video. So here we have been asked to fill the Google Forms along with it. I'll be explaining you the code and likewise going through the project. So let us begin. My name is Swastik Nepal and I am from the British College and here are the details of mine. And I also acknowledge that the codes must be submitted in my bucket, and so I have filled all the necessary informations along with this and also pasted a documentation of this app. So let us move towards the video in which I'll be explaining you about the uses of interface. In BOOSE, we had been given an interface of the BOOSE library itself, and that interface I have extended it to a command factory, an app parser. The iParser has been extended, and also in the app canvas, the iCanvas canvas has been extended to the app canvas. Similarly, the iCommand factory has been extended from the command factory, and similarly we can see that the iParser has also been extended. Here I'll explain you what this does. The iParser with the iParser interface extend and parse the commands that is coming from the BOOSE library. Here we can see that all the counters have been reset. I've made a function for it, or also called methods. Similarly, the reset counter fields and the parse command method. Similarly, in the app command factory, you can see that the commands that are from the BOOSE library have been overridden here and called to the move to. Move to calls the method from the BOOSE library, draw to, circle, rectangle, triangle, and so on. Also, we have handled the exception case that there is an error if the command is unknown. So similarly, moving on to the app canvas, which has been extended, we can see that the canvas size and pen color and the pen brush which we use from the BOOSE library has been set here. We have set the canvas size to uh, we have set the canvas size to 640 into 480, which is pretty good for drawing, and also the pen color, and we have also made the circle and clear and draw to. We have made functions for it too. The the methods that we had in the BOOSE, we have replaced it with these commands. Similarly, moving on to my own interfaces which I have made. Sorry, there are none. I have only used from the BOOSE library. And further, we are moving on to the unit test. While app can come with different failures, we have to have testing to it. So similarly, I have created many tests in my project, so we can move on to that. We have created tests for all the classes, and also we have made separate documents for it. Here we can see it, the BOOSE functionality test, the loop, the testing of the loops, and also the other tests which include multiple methods and so on. Here we can see that the unit tests for all the methods are being run here. We can run all the tests and see. We can just wait for it to build, and the build has been succeeded. We can see that all the tests have been passed. Now moving on to the XML comments, you can see here that the XML comments have been made in the this and we can also I've also built uh, documentations using a ghost doc which shows all the methods and also the test cases that we have listed. And as you can see that for it, the failure is out of bound and the success with the error declarations and so on. So moving on to, yes, I've done it. So you all green text in demo, yes. With the assertions we have made, we can see that we can see all the green text. Okay, now moving on to the design pattern. Here what we have done is we have used command factory. As we can see, I've also explained you before that the command factory interface which we pulled from the Boost library, we have overridden it, and the commands that are there in the Boost library, we have rewritten it to move to, and the move to calls the one that is in the Boost library, draw to, circle, rectangle, and so on. We have seen this already, and yes, I have. And similarly, we have also used singleton command factory. We can see it in the debug console, and in which we have used singleton so that it gives only one instance for the debug console. Whenever the instance is created, it doesn't let create another instance and only uses one instance for the debug console. Here we can see the command for it. The instance is null and it logs the single. Yes, we have done it. And the fact is, while there are no other design patterns in my code, the variables, the boost gives the restrictions. So what we have done is we have made the restrictions go away with our simple commands. As we can see here, we also run the command at first. The one unrestricted ints command which has been given by Arden Muller sir. We can run the command and see here that the program runs successfully, drawing a rectangle at position 100, 200 with dimensions 50 into 75. And we can see here in the app parser, what we have done is we have reset all the counters for boost. So hey, here's how I handle the unlimited integers. Instead of replacing the entire int class, I used the reflection to reset Boo's internal counters. We can see here in the reset all Boo's counters class, and there the Boo's restricts it to three integer variables by maintaining an internal static counter. But what I did here is that before each variable declaration, I reset the counter to 0. I have reset the counter here. You can see it, and the counter is reset to 0, which gives the unlimited integer variables without rewriting the entire class. So put it in the same folder. Now moving on to the real class, what we have done is we can see here in our code section, we can run the code at first. the canvas and clear it, paste it to run here, and we can see that the output is given by multiplying both the real values, which is 155.0. While the restricted one runs, we can also see that to run the unrestricted ones, we can just run it. We even don't need to reset it, as running it will clear the canvas automatically. And we can see here that the real length width assigned to, it has been assigned to a variable, and it learns writing it curve circle as the variable. So you can see here that it runs, but accordingly how the real works is that we can see that the same approach for real variables has been used. Used a flag and the reset counter has been set to null. So the stream strategy has been used for real, in which the boost limits the real to 3, but what we have done is we now similarly moving on to the run the array class. At first we can run the restricted array class. Here we can run the array class, and we can see here it is giving us the right answers. Here what it does is array stores the values, peak retrieves them, and the pen moves to 100, 100 array, and it gives a green color and shows our array command running too. So what we have done is that we have extended the array command here. We have extended the array command. Instead of replacing it, we have overridden the parameters to validate the syntax, and also overridden the process parameter combined to handle peak and poke, and it resets the array counter. Array counter before declaration, which integrates with Boo's existing array infrastructure. So moving on to our assignment, yes, we have replaced it. Moving on to the control statements, or if, while, and for. You can see that we can run the commands and test it ourselves. First, let me remove this and clear the canvas. And here we can see that for if, at first let us run the restricted if, which runs very perfectly according to the command that we have given for pen, and the circle is being drawn while the variable is less than 50. It runs perfectly. And similarly, running the unrestricted ifs, we can see here we can clear the canvas and we can run it, giving us the perfect drawing in our output command. Similarly, for ifs, what we have done is that we have the boost built in class, but we have just bypassed the restrictions, which can be seen in app stored program, in which the stored program interface from the boost has been called, and in which we have used we have overridden the run commands, in which that we have done is in the abstract command we have overridden the overridden the command, and here we can see it tries to conditional command and we have also reset all the counters for it too. While the boost handles all the limits, I have just while the boost handles all the logic, I have just removed the limits for it. The stack-based execution is managed by stored program here. Run the while restricted while command. You can see that you can see that first clear and run, and we can see that the while command runs a loop around it and creates square creates a square of 100 and 100. Accordingly, similarly, we can run for the two unrestricted commands. See here it runs flawlessly, giving us the circles and the squares as needed. Similarly, the for the while command, we have been using the boost built-in functions, but just the restrictions have been lifted for the counters before parsing. Boost handles the logic, but I just remove the limits from there. It resets the boolean and the while class counters. The boolean boost evaluates condition before each iterations. My code just removes the limit. Okay, so moving on to the runs and moving on to the for. At first we can run the restricted for. You can see here we can run it. We don't need to clear the canvas and it does automatically, and we can see here a concentric circle around the step of tilt has been made in my canvas. Similarly, running the unrestricted force, we can see that it creates an amazing spirals and circles around it with different colors, moving it from count count and using the for loop. And about how I have done it, we can set the same counter to reset for boost, and the counter has been reset for and runs same as the control loops. The control loops and the method have all been handled such that it resets the counter, and we can run the commands. The boost handles the start and end step while I reset the restriction counter, which allows me unlimited nested loops. The variable scope is managed by Boost itself. Now, moving on to the methods, we can at first run the methods which has been given. Here, slightly adjust the methods and run it, and we can see here that the method has been called and it is up and running. So how we have done it is in the app parser, we have methods. We can see here the parse command in which the methods go here, and the boost counter is reset, which runs the methods, while boost handles and limits the methods to 1 by default. The reset boost.method resets the counter for local variables, and my boost handles the boost handles calls and stack and returns the value, while my code removes the artificial limits. What my strategy with this was, we don't need to rewrite the boost, just use its existing classes, use reflection to reset the internal restrictions, and use counters. Reset before each declaration for int, real, array, and method, and etc. Extend the boost classes where it was necessary. Similarly, moving on, I can see that the boost method is running, and we have the file. While I have added many different functionalities in here, as we can see, we can clear and reset and remove this. You can also see the dark mode and the light mode. And here I have added quick commands to move to, draw, circle, and all the other things. What it does is, when the move to is created, it gives a command and the syntax with it and the parameters that need to be filled. So we can do move to 100 to 100, and we can create a circle with the radius which is given here. If we don't know the parameters, we can simply see here the circle gives the radius, and we can 100 and run the command, which draws it exceptionally well. So on how I have done it, I have created a dictionary for it in the form1.cs. I have created a dictionary for the list of keywords, and I've created a list of dictionary for it, and in that I have given the commands along with it. So for what we need to, this is for the autofill, and the commands will be given for the autofill box with the commands, and I have given the command here with my private methods. So similarly, we have also done the save and the load canvas. So if we want to save the image that is here, we can. So what other things that I've done is, I've also added in the new commands of my own, and I have added my programs. Can quickly run it, and here I have created my own command which creates with different colors a spiral circle along with the for loop we can see here. And similarly, my other command is drawing lines using the functionality of the boost. You can see here different lines. What I have also done is, I have created a save canvas and the load canvas. In this, while giving the save canvas, we can see we can choose where to store our successfully, and similarly we can clear the canvas, reset it, and we can load the canvas, and from the desktop we can create a boost which gives the canvas to load successfully. For it, we have initialized a bitmap app variable, and here we can see that the app canvas sets the graphic and the bitmap size, and we can get the bitmap the get bitmap function. And similarly, I have also added for triangle and to right and so on. But I have used Ghost Doc Pro to create my documentation. It is the inside our syllabus. So yep, thank you for watching. This is my video on how to use the Booze app, Booze library to create our command. Thank you.